let's solve this problem. Okay, LeetCode35, search insert position. So for this question, given a sorted array of distinct integer and a target value, and return the index if the target is found. Okay, so for this example, 1, 3, 5, 6, the target is 5. So we return the index is 0, 1, 2. So we return 2. Okay, so if not, return the index where it would be if it were inserted in order. So that means that, let's say this one, the target is 2. In the numbers, we don't have a 2 in this array. So the 2, actually, if we insert 2 in this array, it's going to be in this position, right? So between 1 and 3. So we always insert it in order, is a 1, 2, inserted the index 1. Here is 0, here is 1. So we return 1. We return 1 here. Okay. Let's see this one. The numbers equals to 1, 3, 6, 5. The target is 7. It's supposed to insert here, right? So we return this position 0, 1, 2, 3, 4. So we return the 4. So this is basically the problem. Okay, so first, for this problem, we can use we can use the brute force algorithm, but the time complexity will be O(n) because we iterate start from 0, 1, 2, 3. You know, if we do this way, the time complexity is O(n). But here we are talking about we must write an algorithm with O log n runtime complexity. So whenever we see this log n, so we can think about binary search. Okay, so what's binary search? Let me give a kind of a introduction of binary search, the definition of binary search. So binary search is an algorithm that divides the search space in two after every comparison. Okay, binary search should be considered every time you need to search for an index or element in a collection. So for our question, we are searching the position of the target value, and then we are we are searching the index of this target value. If we found, we just return the index. If we are not found in this array, we just put it where it was sorted. So if the collection is unsorted, we can always sort it first before applying binary search. But in this case, this array is already sorted. So we have 3 sections of the binary search we need to think about. Okay. So we have 3. So whenever we think about binary search, what we need to know, the left pointer, the middle pointer, the right pointer. Okay. Also, we have 3 sections. We need to do pre-processing, and then we do binary search, and then we do post-processing. Okay. So what's the pre-processing? Pre-processing is kind of talking about we have to sort it. So we need to sort the array if this array is unsorted. Okay, if this collection is unsorted. So in this case, we don't have to think about this part because it's already sorted. Okay. And then we do binary search, and then post-processing. Post-processing is like, actually it depends on the search condition. We will talk about that later when we coding. Our search condition, it depends on the candidate, and also if we check the neighbors or not. We will talk about later once we coding. Okay, so for this problem, let's give an example. Let's give an example of this one. So, okay. For here, we can initialize L is here, R is here. And then this one is going to be the M. 3 is the M. And then we check 3 smaller than 3 smaller than 5. So what do we do? We will update the L, the left pointer, to the middle. And here is the right. And then the middle of the new iteration, it will be like this. And then M is 5. Now 5 equals to 5. So what are we going to do? Once the 5 equals 5, in this case, we update the right because we're going to insert the target to this exactly position of here. So we update the right. In this case, we update this one. So this one is L. This one is R. Okay. Our search condition. So our search condition actually, we can actually check, do the post processing to check post processing going on here. Post processing needed here. Okay. So we will talk about later when we're coding. Okay. So this is one example. Like this example is like when 5 is found in this array. So let's get another one. This one. So what if the target, we cannot find it in this array? Let's do it. Okay, let's do this one. So here is L. Here is right. Okay, the M is here. So the M is 3. 3 smaller than 5, right? 3 smaller than 5, then we update left. Here is right. And here is M. But here is M. Oh, sorry about that. Here actually is 2. Sorry about that. So, okay, the 3 actually greater than 2. So when 3 greater than 2, then we update the right. Update the right. Okay. And then the while loop stopped. Okay, that's the search condition. So this is an example we are gonna to do. And then after we found this position, this one actually greater than 2, and then we just actually insert the 2 to here. That's basically we are going to do. So when we do the binary search, so we are going to actually stop back here because our while loop condition, our while loop, the search condition will be L plus 1 smaller than right. Okay, so this what do we do? So that means what? Like L plus 1, it will be here, and then it will equals to the right, right? L plus 1, if they are neighbors, so L plus 1 will equals to the right. It's not satisfy this condition. That means when L and R, the left and the right, when they are neighbors, our loop stopped. This is already stopped here. So but we haven't checked the 1 and the 3, so that's why we need to do the post processing needed. So we need to do the post processing after here. So basically this situation, it will looks like left, right. So one stop, like this left and this right. So they are neighbors. They are neighbors. Okay. Yeah, they are neighbors. Okay, so if they are neighbors, the stop the while loop. Okay, stop the while loop. Okay, so let's talk about this one. So what happens if the target equals to names middle? What happens if we So if the target found, we move, in this case, we move red pointer to the middle. Why? Because since our third position should be less than or equal to that position. Yeah, because here it shows like if not, return the index where it would be if it were inserted in order. So we need to insert that one in the right one, in that position. Okay, let's start coding. So first, let's check here the constraints of numbers length greater equals to 1 and smaller than this one. That means that we don't have to put the we don't have that means this numbers is not none, or this numbers is not the length is not 0, so we don't have to check the corner case. So if left equals to 0, so we start initiate the right equals to numbers.length minus 1. Okay, also we need to pay attention about the input of this problem. So the input is the array, the sorted array is given by the problem, right? So it's the array and a target value. Here is target value. So return the index of the target. Here is the index is int. Okay, you return the index. Okay, so I have to pay attention about this part. Okay, and then what are we gonna do? We're gonna do while loop. When we do while loop, we do left plus 1 smaller than right. Okay, smaller than right. Okay, we just talked about left plus 1 smaller than right. So the stop condition will be like this, left, right. And then we haven't checked the left and the right, the value of that. So we need to do the post-processing after that. So, and then we computing the middle. We're computing the middle is like a left. Here is a right minus left, and also by 2. So what does that mean? That means that we are trying to avoid overflow. We are trying to we are not doing like a left plus right by 2, right? So by why? Because we are trying to we write it this way because we're trying to avoid overflow. Okay, and then we check if the names middle smaller than the target. If it's smaller than target, what do we do? We're gonna actually update to the left, right? We just talked about that. Otherwise, else, we're gonna check. Otherwise, we're gonna update the middle to the right. Okay, so this is basically the while loop. And after the while loop stopped, when they are neighbors, okay, we're going to do the post-processing. As we just talked, here is post-processing for the binary search. So when we do post-processing, we are doing target smaller equals to names and left. Okay, when we do this, what we do, we return the left. That means that when we check the left, if the target is smaller than or equals to the left, then we return the index of left. Why? Because if the target equals to left, we just directly return. If it's smaller than that, that means we should insert the target to here, to the left. Okay, so else if is not, if target is greater the number of left, else if the target smaller than or equals to the names right. if in this condition, what we do, we're going to return the right. Okay? And also, we will return the right plus 1. That means that our target is greater than the right, like this. If greater than the right, we just return the right plus 1. Okay, this basically this problem. Okay, thank you for let's actually run the code. Okay, it's accept. Let's check the text case. Test case C is 1356 and the output is 5. Yeah, there's no problem. And then the time complexity for this problem. Complexity for this problem is a big O log n, and then the space complexity is big O 1 because we don't use any extra data structure. So okay, let's submit the code. Okay, our code faster than 100% of Java Online submission for this problem. Okay, thank you for watching. I'll see you next time.